I am Ted Goldstein, structural engineer with Atlas Tube, and we are here at the NCSCA 2025 Summit. It's the month of October, so we're looking at spooky connections, and we're going to jump in with the HSS Connections Hub. Today we're looking at an overlapped round K connection. Some engineers might find this a little bit spooky. Got to get into Chapter K to get all the various limit states and limits of applicability, but fortunately the HSS Connections Hub is going to check all that stuff for us, so it should be pretty easy to put together a connection and make sure that everything works. So let's jump in.
So here we have a round overlap K connection that I've set up. Very simple. I've got equal loads on the two branches. I've got the member sizes in there, and right away we're seeing that we're getting a fail up at the top here. And this is not just from overstress, because if the connection were overstressed, we would have a percentage there that was greater than 100. In this case, we've got a geometric issue. It says the overlap needs to be between 25% and 100%. That's based on the limits of applicability from Chapter K of the manual. And if we scroll down, we'll see that our overlap down here is actually only 23%. So we're very close, but not quite enough. And the way we can modify that is using the eccentricity values. So here, if we go to eccentricity, of course, we have an explainer on how that dimension relates to the work point and how you can adjust it. I'm going to go ahead and put a negative value in here, which is actually going to move it up based on the way this is laid out. And when we do that, we can see that now, instead of having fail at the top, we have 112%. So we now have enough overlap that the connection is within those limits of applicability, but the loads right now are beyond what the connection can handle. And what we're going to find is that if we start trying to change the amount of overlap or potentially some of the other parameters here, it's going to be very difficult to get that number down. This is based on chord plastification, which has a lot to do with the strength of the face of the chord member. And generally speaking, there's only so much you can do to get that number to change. And so what we're going to have to do is actually start adjusting the member sizes. And this is really to illustrate how important it is to take the connections into account ahead of time when we're designing the truss, as opposed to just designing the members and then assuming we can get the connections to work. So we have a couple of options to get this down. The most straightforward is to go ahead and make the cord a little thicker. So if we go from a 10.75 with a 1/2 inch wall, and we now move to a 10.75 with a 5/8 inch wall, we can see instead of being overstressed at 112%, we're now down to 77. So plenty of capacity for that change. The other option is if we go ahead and go back to our original cord size, so 10.75 with a 1/2 inch wall. Now, of course, we're back to 112%, the overstressed amount. We can actually change the diameter of the branch member. So if we do 8.625, so 1/8 and 5/8 wall, and keep the same thickness at 3/8, and then go ahead and do that to both members, we will see now we've got the number down and we're at 95%. So again, the connection works. Now, it's pretty obvious why increasing the cord thickness helps us. It makes the face of that cord a lot stiffer and stronger to handle the load from the branches. By increasing the branch diameter, it actually spreads that load over a wider portion of the cord, engages more of that material, and also engages it where it's stiffer near the edges. So a few different options you have in this situation, but again, it's very important that we look at these issues ahead of time, make sure that the connection engineer on a project is not forced to address them after the fact, because in the end, if you couldn't change the member sizes here, there's a good chance you would have to start introducing reinforcement, which not only could affect the cost of the connection, but of course the aesthetics as well. So this has been the overlap K connection for the connection of the month, in this case our spooky connection of the month, and we hope to see you again next month.